best way to actually and we thought the best way to introduce what we're doing is to actually have webinars twice a week. On Tuesdays, we have webinars based off of just an understanding of what data engineering is, what you would actually learn in the boot camp, and why that would be beneficial, and all the statistics that come along with it. Then on Thursdays, we dive deeper into tools that a data engineer would use. So today we're talking about cloud-based, is it Google Cloud-based services, and we're going to explain those. And we're joined with Guy and Par, and they're a part of DataStack Academy too. So they're going to be the ones teaching you, mentoring you if you do decide to do the boot camp, which I actually even want to go through the boot camp too. I do a lot of the marketing and behind the scenes things. But anyway, it is time for us to get started. So if you guys have any questions, feel free to put them in the chat box, and I will make sure that Par and Guy know to answer them, or you can ask them at the very end. And if we didn't answer any of your questions during this webinar, you can also email me at cj@datastack.academy. And Par also has an email there too, and I'll put that in there. And then also, actually, before we kick off, I know a couple of you, but if you could tell me where you actually learned about the webinar today, like did you find it on social media? Did you find it through LinkedIn? Well, through LinkedIn is social media, but through our emails. We just like to know, because again, we're all about data, so we want all those analytics. So yeah, if you can put that in the chat option, that'd be wonderful. And I guess the floor is yours now, guys.
Thanks, appreciate it.
Thanks, CJ.
Yeah, thanks a lot, CJ. So today we're here to talk about the Google Cloud Platform and all the data, specifically the data stack that they have there. There's quite a few, so we're gonna get started. We're gonna go fast, and we're gonna try to get through all of them. And that's a fair warning. This presentation is going to be a fair bit of slides, and it's going to be a fair bit of bullet points and talking about these services. We went back and forth a lot to see how we can make it exciting. We have a demo towards the end, but it's just not a good, we couldn't find a good way to go through a lot of material that we want to go through without a lot of words per se. So again, fair warning, it's going to be a little word heavy, but we're going to show you the different stack that Google Cloud has and why you would use them and how they're used and when you want to use them. We want to get that information to you as fast as we can. And again, like I said, Guy is going to take you guys through the demo at the end. Very quickly, some numbers on data engineering. Data engineering is in general the field, and I say this with absolute certainty and sincerely, in my 25 years of tech career that I've been in, it's the thing of the future, is the fastest growing field in tech. In 2020 to 2021 pandemic year, 81% of the companies that were surveyed by Butchworks, 320 companies, hired data engineers. That was the biggest number out of any field in tech. Average salary for data engineers right now is $119K per year. There's 40,000 jobs on Indeed. You can go check Indeed yourself. The biggest number here is the 50% growth. Again, that's for Dice report, Dice being the most accredited reporting agency out, tech reporting agency out there. They analyzed 6 million job postings for this, again, in pandemic year, and data engineering saw a 50% growth. It was nearly double the second on the list, which was data science. So it's, and I'll send you the slides, I'll send you the sources for these. Don't take my word for it. Again, this field is growing, and it's here to stay. I don't see data going away, so it's not a hype. I know we go through a lot of hypes in tech, but this doesn't seem to be a hype. Data is not going anywhere unless we have a huge catastrophe on this earth, right?
Yeah, companies aren't going to have any less data anytime soon. So
yeah. So as a whole, we've, oh, sorry, Guy.
So this is just at the highest level, just a general overview of what makes up the Google Cloud Data Stack. There's a lot of individual services, and we're going to walk you through the details of quite a few of those, especially as it relates to data engineering pipelines. But just in a general way, this is a way to think about it. So we have individually, we can divide this data stack into storage and databases. Compute, which is obviously the actual computing power and the processing of our data, and then analytics and visualization, which is at what we call the front end, and the consumers of data and people make decisions from it. And then over all of those things, we have a layer that we call orchestration, which is automation, scheduling, messaging, and the pieces that tie all of those other individual things together for us as data engineers to make data pipelines or to make complete applications on the cloud.
Nice. So let's start it off. Let's go through storage. So we're going to go through each one of these pieces. So as a data engineer's analytical stack, you kind of have these slew of storage options. At the very base, your backbone is Google Cloud Storage. That's like a giant file system. And then BigQuery. That's your initial landing space. You cannot go wrong. You pretty much land your data always there, and you go from there. So, and I'll dive into this a little in detail, but cloud storage and BigQuery being the SQL interface kind of on top of the cloud storage, that's your starting point. Can't go wrong there. If you want more sort of database, relational databases, you have things like Cloud SQL and Cloud Spanner, which would go in, but that gives you a traditional like kind of database feel on the cloud. Traditional like MySQL, Postgres, that sort of feel. Then there's applications that require low latency, where they tend to be really good for applications where information is coming sort of in pieces, and you want low latency to update those information. And then you have your NoSQL sort of storage there, NoSQL data stores, Bigtable and Firestore being one of those big two, again, for when the information to your analytical set is coming in pieces and coming in small little updates. So those are really good for that cases. I'll dive into that sort of first stack, being the cloud storage and BigQuery. Like we said, cloud storage is like a giant directory, right, on the cloud. It's the initial landing space. When you land your raw data, you always land it there. It's very good for unstructured data. So if you have files, movie clips, stuff that are unstructured, it always goes there first. Again, you can't go wrong. Use Google Cloud, store your data there. Then what you do, you use a variety of different applications that Google provides to process that data, that can and all of those applications like BigQuery, Dataproc, stuff that we're going to talk about later, would process that data and build some structure on top of it, and they can all interfere and interface with cloud storage. What I would say here is that use tags a lot. That's a really good way for you to organize what's on cloud storage, and then be able to later on search those with the tags that you've put on the cloud storage. The other nice thing is that cloud storage has tiered storage, and there's different price for those. Use those. So the data that is hot, that's coming, that you want to have faster access to, you store those as more high tier or hot tier. But then you can have retention period, where you slowly move those into more cold storage when it's actually cheaper. All right, so, and then BigQuery is your SQL on top of cloud storage. It's the backbone of the analytical stack on the cloud, is where you can, and a lot of times I would say you would land data in cloud storage and then define external tables. So table that are externally managed on data storage, but you get SQL access through BigQuery through those. So use external tables a lot on the BigQuery side. But right there, I mean, BigQuery connects to all the analytical and data science tools. So right there, you can get decent amount of analytics from BigQuery, and you can get a lot of good visualizations just by, the storage in BigQuery. The other thing that people do is that they use BigQuery as an ELT service. So after you've landed it there, you can use SQL to transform your data. And that makes things a lot easier.
Okay, so now let's look at a couple of relational SQL options for database options on BigQuery. So when we talk about relational databases in SQL, the relational database model is something that's been in use for decades. It's very time tested. Despite some newer trends, it's still the backbone of the data world. And Google Cloud gives us multiple different options of SQL-based databases. So the first one is called Cloud SQL. And this is something that is more of a traditional style of database for how databases were implemented even before the cloud. So Cloud SQL is still in a lot of use, but it's more for legacy application support at this point. It is a good option in some use cases, but there's better, more advanced options now like Cloud Spanner, which I'll talk about in a minute. It integrates, Cloud SQL integrates really easily with, again, existing applications and with non-cloud SQL. So that's part of the primary use case for it. And it's good for migrating older applications. So Cloud Spanner is a newer option that has some really advanced technology. It's also relational, also uses SQL, but it provides features like automatic scaling, which Cloud SQL doesn't have. So with Cloud SQL, if you want to scale your application, you have to go manually spin up new instances of your database. Cloud Spanner handles that for you automatically. It's higher availability. It has another feature called sharding, which refers to taking a single data set and distributing it among multiple databases. So again, a very, very advanced feature. So Cloud Spanner is a new, more modern update on the relational SQL model. As with all the cloud services, there's differences in pricing and the pricing structure. So depending on the exact details of your application, there's a lot of different use cases. And it's, Cloud Spanner, even though it has newer features, isn't necessarily always the way to go. But Cloud Spanner is something that has a lot of amazing advanced features. And it's one of the really strong features of the database stack that Google Cloud provides.
I would say if you're like on a new application, you kind of go on the Spanner usually. But if you're migrating older applications, you would do like Cloud SQL. You don't want to change the code as much, right?
Exactly. Yeah. If you have an existing application that you want easy integration with, Cloud SQL is great. Definitely. Yeah. Okay, so now let's look at NoSQL. This is a term that maybe some people have heard of. This is a newer trend in data storage and database technology. So starting in the late 2000s, as storage costs were decreasing dramatically, the cost of software developers and paying developers became the biggest cost. And so there was this trend of looking for database technologies that were more flexible, that didn't have the same kind of well-defined data model that SQL databases use, which takes a lot of work up front to define that data structure. So NoSQL databases are a newer, more flexible, and in a lot of cases, higher performance option that have definitely seen a lot of attention in recent years, even though SQL is still the backbone, as I said, of the data world. So there's a couple different options on Google Cloud for NoSQL: Firestore and Cloud Bigtable. Firestore is more of a document database that's based on JSON, which is an object notation language that we work with a lot as data engineers. Firestore does really easy integrations with mobile and web, different type of applications. Cloud Bigtable, there's a lot of differences in the technical details, but in terms of how it stores the data, it's kind of like a giant Excel spreadsheet. It's what we call a wide column database. The latency with Cloud Bigtable is lower. So depending on your application, if you have maybe more of like a streaming data type of application where you have data coming in frequently in real time, Cloud Bigtable is probably a better option in that case. So for applications like Internet of Things, ad technology, streaming, those are things that would be good use cases for Cloud Bigtable. And when data arrives, as Parm said earlier, in pieces or in a streaming fashion, Cloud Bigtable is really good. So these are a couple of the NoSQL options, and NoSQL is something, depending on the details of your application, that might be a really good solution if you need that kind of streaming high performance.
Okay, great, thanks, Guy. So jumping on to compute. So what are your options when you're doing, again, we're thinking mostly data engineering and processing of data. What are your options there? And we've listed few, so we are not listing all the compute options, of course. We tend to very pitch, like Guy and I, in general, serverless. That's the way, that's a new way to go with the cloud. It's you don't have to manage servers and compute that you have to like deal with them. It's like, oh, did I spin something up? Did I take it down? But B, all that management is done by the cloud. So great. B is they're a lot cheaper. the cloud vendors like them better because they don't dedicate a server resource to you. And every time they don't have to dedicate a single service to you, they can sell it to the other people and they can kind of sell it in pieces. And that's the business of the cloud. So they like it better. They can offer that a lot cheaper to you. It's kind of, I want to say, categorizing in this two-way, I would say, like, so you have things like Cloud Function and Dataproc, which seemed a little bit more like procedural languages for lack of it. And I say this because like you literally build one function, one script that does a single thing, and those like work better in that sort of terminology in data integration. So if you have like you do one thing, they're really good fit for that. And the Docker way, like you have like Cloud Run and the Kubernetes, things that you package in a Docker image. I want to kind of think of them as more like object-oriented, because then you can package different things like object-oriented programming. So you can have multiple things that you kind of package in this well-contained image that you can run everywhere. So generalizing very high level there, that's kind of like the thinking here. Cloud Function is the one that we're going to go through first. Use these all the time. It's the first thing. So if you want to process something on the cloud and your first thinking, always Cloud Functions. They're extremely easy to deploy. You literally just a function, right? A function in any programming language that you like, mostly Python, JavaScript, Go. And with one command line command that deploys to the cloud and it runs. They're also triggered, so you can trigger them on events that happens on the cloud for you. So you can trigger them actually when a file is stored on the Google Cloud Storage, or when later on, guys, going to show you a message goes to a pub sub. It's great. You can in real time, and it scales endlessly. So in real time, you can process a file or a message or a data point and get the results from immediately with the Cloud Functions. Can't go wrong there. Your first initial. So Cloud Run it's the next step from that. So it's when you can package. So it's when your application is just not one function in like Python or so, one script. You need more things with that. You can then pack those into a Docker image and then run that Docker image on Cloud Run. And again, they can be trigger based. The triggers are not as vast. The trigger options are not as vast as what Cloud Function provides, but they're following up. And actually behind the scene, Cloud Functions are actually a Docker image that runs on Google Cloud. So those features usually tend to make themselves into the Cloud Run features. So in Google Kubernetes now, it's the bigger version of that. So Google Kubernetes is great when you have then multiple even Docker containers that you need to orchestrate. So when something you want to do is not just even a single Docker containers, when it has to have different pieces, that's great for that orchestration. For data engineering specifically, a lot of people use Google Kubernetes Engine for like ML ops. They also like this, again, big event driven where it needs to be on demand. So some big data processing that requires multiple Docker containers that needs to be on demand. That's great for Kubernetes. Last but not least, again, Dataproc, which is your Apache Spark. That is great for like sort of your backbone data processes that you're trying to optimize. So if you've got to the point that like, okay, you're doing a lot of things and mostly in batch, and you want to optimize those to run at scale, but you run those every day. They're the things that you do every day, all day, and you want to optimize those, then Dataproc, Apache Spark is the way to go. And what we say is you use transient clusters there, because this is not serverless, it costs money. But you spin off a cluster, a Dataproc cluster for a particular task that you want to do, for a particular series of tasks that you want to do. You jam pack them all together, you run them at once, then you delete that cluster. So don't have these clusters that are in the back, incurring costs. Kill them after you're done with them.
Okay, so the next thing we want to talk about is orchestration. As we mentioned earlier, the orchestration layer is the thing that ties all the other individual pieces together. And we'll look at the individual services in a minute, but orchestration deals with automation, scheduling, and kind of the things that hold your whole application or your whole pipeline together. So let's look first at a a GCP service called PubSub, which is short for publisher subscriber. So PubSub is basically the messaging framework. So when we're doing cloud software and data engineering pipelines, the whole cloud paradigm kind of implies a new way of building software. And you might have heard the term like microservices or like decoupling, because in that model, all the different services are autonomous and they're not aware of each other. But when you build software data pipelines in that way, the messaging element becomes that much more important. So PubSub is, as you say here, it's like the glue that holds a lot of the other pieces together. There's a topic and subscriber architecture with PubSub that's very basic building blocks, but that can be combined in just an endless number of ways to build architectures that can do essentially anything. So this PubSub lets your different services talk to each other and gives you some material for structuring your data pipelines. Cloud Workflow and Cloud Composer are the two orchestration services. And there's some differences in the details here. Cloud Composer is built on another Apache project called Airflow. And Composer is the Google Cloud's implementation of that open source project. Workflow is serverless, as Parham's been mentioning. The serverless paradigm is just such a great way to go because it takes a lot of the administration and management details off of you as a developer or a data engineer. Both Workflow and Composer provide orchestration tools, but there's a few differences. There's a difference in latency. So Cloud Workflow is lower latency, so it's better again for like HTTP-based API services or applications where you need a much quicker response, like if you have a streaming real-time data application. Composer, the latency is a little bit longer, but as data engineers, we tend to work more with Composer because for our applications, typically the data processing doesn't have to happen necessarily in real time at millisecond latency. So Composer is a tool that we use a lot, but depending on the details of our implementation, these are both tools that we might work with. And Google Cloud is great because they provide excellent implementations of these open source tools and give us a lot of options for how to build our applications to meet any need for a data pipeline.
Composer, like Airflow, you can build really complex like kind of pipelines with it, where kind of Workflow, like you can just can start there, and there's not that much complexity, but if that hits what you need, especially for orchestrating cloud functions, then you're off to go there. Yeah. All right, so last but not least, the analytical stack. So the data visualization and analytical stack, and Google has a lot of that. Your first one and easiest one to use, Google Data Studio, right? You can spin that off. It's very easy. It's kind of like your Tableau or Power BI, or a smaller version of those two on the cloud. It's really nice. You can share the visualization. You can, as a data engineer, you don't have to be like a data analyst and know how to use these tools. It's very easy to learn. So you can go there as a data engineer, and with a couple of drag and drops, you have a graph and you can show your result in a visual way. Do that a lot. Again, as a data engineer inside a company, I know a lot of things that we do, it's not visual, it's processes, but people really like visual stuff, right? So a lot of times when you can actually show the result of your work in a visual way to other people, that has great results for you within a company. Data Lab, I think, is the next level of that, where you can use Jupyter Notebooks. So it's Jupyter Notebooks on the cloud, and you can use the visualization. So you can use your Python skills and create a notebook. And in the notebook, you can create a story around your process and data. So you can put your code there, but you can also build these graphs, but you can also put markdown. So you can actually build a story and explain what you're doing. Great way to share your work with your colleagues within a company. Of course, BigQuery has a lot of analytical services with SQL, and it has ML. There's even a lot of ML packages that are available in BigQuery that you can do. Everybody knows how to use that. You got to use BigQuery at some point if you're a data engineer on the cloud. So that's a no-brainer. The AI platform, so Google provides, and this would be a whole webinar on its own, but there's a lot of these packaged AI solutions on Google Cloud. Now, we're not going to get into each one individually here because it would take forever, but all of that is available too, especially for a lot of, again, unstructured. Those are really good if you want to do like things like speech to text, image recognition, all of that stuff is there.
And one more small thing I'd add to that is that as data engineers, we typically work more on what we call the back end, but familiarity with these analytics tools is really important, because one of the biggest things in our role as data engineer is a lot of times you're interfacing with the data analysts and the data scientists. So even though you might not necessarily be building the analytical reports, having familiarity with these tools is really important, because you're going to be working closely with the people at R. And so you need to have a good understanding of how to get them the data that they need so that they can build these reports. Yeah.
Awesome. Yeah. Thanks, Guy.
Okay, so this is a lot of information. There's a lot of services. I remember when I first got into cloud, it was kind of overwhelming. There's a lot of information. And so we've given you a lot of information about the different pieces, but to help kind of get the big picture of this, what we've done here is we're going to do a demo of like a sample start to finish data pipeline application. This is something that we've taken from chapter 9 of our bootcamp course, which is on streaming cloud architecture. So we have a little mini data pipeline here. So what happens is at the beginning, we're going to start with a JSON file of some data. It's some ticket data from like an airline. And so what's going to happen is we put that into a Google Cloud Storage bucket. The information is parsed out of that file and it's published to PubSub. PubSub is our messaging piece that lets us use topics and subscriptions to let our different services talk to each other and send messages. So PubSub kind of sits in the middle and connects the ingestion and the processing portions of our pipeline. So the processing portion of the pipeline is kind of a two-stage. We're going to read trip data out of the tickets file and create a pandas data frame with that. And then we're also going to extract some passenger data from that ticket data and create a separate data frame. And then at the end, there's a write stage where that data is going to go into BigQuery, and we'll see that at the end. So let me show you, give me a second to pull up here. Let me show you real quick just the individual pieces before I run this. So we've got to
make this full screen by any chance here, guys?
So we've got a
maybe go a couple font sizes up. I'm sorry.
Yeah, no, it's all good.
How do I do that? Oh, there you go. Making this a little bigger so you guys can see it. Sorry.
So we have an empty Google Cloud Storage bucket that's going to hold our file. Then this is the amazing GCP, the Logs Explorer, so we can watch in real time after we land our file. We'll be able to see the data go in and process through our messaging component and go into BigQuery. We have a couple of helper cloud functions. As Par mentioned, cloud functions are the serverless single-use functions that are really good for, they can be triggered and perform different kinds of processing. We've registered a couple of those.
Use them.
Use cloud functions. Yeah, Google Cloud, it's great. They have this browser-based interface. So once your cloud functions are registered, you can see the source code, see and edit the source code. You can see the related configuration files. They make it, Google Cloud provides amazing tools and interfaces to work with your cloud architecture components. Then on the messaging piece with PubSub, we have some topics that we've registered and some subscriptions to go along with them. So that the messages will be read from our data into the topics, and then the subscriptions will provide those to the processing portion of the pipeline. And then we have a couple of cloud scheduler jobs. This is an orchestration component. These are scheduled to run every 5 minutes, but when I do this example, I'm going to trigger those manually just to save a little time so we don't have to sit and watch. So what we're going to do here, I'll show you is I'm going to copy. Here's the ticket data in JSON format. This is the file. So I'm going to copy this to our Google Cloud Storage bucket. Move that. So
Zoom thing is always in the way.
Yeah, Zoom window. So I'm going to copy this file, and we can see that uploading. And I'm going to go back into my browser. So now,
so you just posted a bunch of messages to PubSub. So from your data, or
right. So this is, I just uploaded this tickets.json file to my Google Cloud Storage bucket.
Google Cloud Storage, yeah.
So we have a cloud function that automatically tests for the existence of this file and then starts to read messages out of it. So we can see, and we'll go in Logs Explorer here, and let me update this and make sure.
That's great. So that demo is like
recent.
That trigger based, again, cloud function. So we did our processing as soon as the file was uploaded in Google Bucket, our cloud function kicked off, and that's processing the JSON file.
Okay, and we'll wait a second for the logs to load here. Always waiting on something. Hold on, let me just reload this page.
This
and maybe
usually
that'll
happens
help.
like immediately.
Right. Yeah. This is probably just a latency issue here.
Demo effect as always.
Yeah, demo effects.
Oh,
Okay, well, anyway, you can see the log explorer will show us. We expect this to happen in real time, but I'm going to skip over this so we don't have to wait too long. But there's our cloud functions have been triggered. There's processing happening. We can go in here. I'm going to go in here and trigger these cloud scheduler jobs manually so we can see the other end of our pipeline.
and this one, so now the schedule thing, so things go into PubSub. So we had a cloud function that took JSON file and put it into PubSub events, and now the scheduler is reading PubSub and then doing further transformation on that and then loading it into BigQuery, right?
Yeah. So let's give this a minute to run. Our data is being processed.
So that shows you guys like how you can use, again, the cloud functions more in a batch or scheduled way, right? So when you have these things in PubSub, you kind of use PubSub to queue up a lot of events, but then every 5 minutes you can go through those and see what's in your queue and process those and put it in BigQuery.
Okay, and we can see here now there's data in our BigQuery table. So we know even though the logs are taking a little while to show up, we know that our application is run because we landed our ticket data in our bucket and it went through a couple of processing stages, and now it's been put into BigQuery tables. BigQuery, as Parm mentioned, is Google Cloud's amazing unified analytics engine that's also a SQL database, but makes it easy to interface with Data Studio and these other things. So you can see this is an example of something that as data engineers, we do this kind of thing all of the time. I mean, this kind of pipeline is something that you'll be working with frequently to read data in one format, process it in some different stages using messaging and other components and orchestration, eventually land it into a database or into BigQuery, and then it's available for analytics and further processing. So hopefully this gives you a little more of an idea in practice of what we're talking about when we talk about a data pipeline, which is a term that we use all the time as data engineers.
That was great. Thanks a lot, Guy. Yeah, appreciate it. And you guys see that in real time. So again, a big portion of that is the serverless effect in that demo, right? Because everything was pretty much serverless in this piece. We did serverless cloud function to ingest the original JSON file. Then we even used the serverless scheduler and cloud workflow to schedule further transformation of messages from PubSub into BigQuery. And all of that, you see it happen in real time. And as we were clicking, all that data went through.
And this is something, the orchestration, the automation component, this example application gives you an idea, because if you're working for, as an example, an airline or some company that has just a tremendous amount of data coming in all the time, it's important to have an automated pipeline to handle that process, ingestion and processing, because there's just so much data that if you're not using cloud functions and these serverless technologies to automatically manage the processing of that data, then it's impossible to keep up.
So I want to take a step back and kind of like, because I think there's some really good information here about just becoming a data engineer. And what's your next step? How to become a data engineer, especially how to become a cloud data engineer or Google Cloud data engineer. There is a self-learning path. People go through and teach themselves, and that's a great path. I would highly recommend that you start by going through one of the cloud certification programs. So Google Cloud has an associate level data engineering certification. Great place. They list a lot of resources on that actually website. They have a learning path and a lot of free resources that you can go through and prepare for that certification. That will get you a huge kind of foot in the door, a huge step when you're applying for jobs. If you put that certification on your resume, then that really shows, you know, you're different from the rest of the stack. I look highly on that for applications that I get. I would say when you self-learn, the biggest thing is like start building your GitHub profile. So when you're doing projects, make those projects, make a Git repo for them and show that on your GitHub, because when you go to employers, a lot of employers are using GitHub as a place to vet resources. Code doesn't lie; it shows your skills, right? If you want your hands on real-time app data or projects, Kaggle is a great source. It has a lot of real-time, real-world projects there. Data Hub IO is another great one. And then there's a whole series of resources on YouTube, especially in these paid online programs like Udemy, DataCamp. They have courses specifically, again, for those certifications or to teach you these cloud technologies. There's a second path, is the boot camps, is what we have as DataStack Academy. That's a very focused group or focused program where we put you through a 3-4 months process. It's very good for people who are new to tech and don't have a lot of background. And it's very good for people who kind of have that declared intention. They're like, all right, data engineering is what I want to do. And you go through this course and you come out and you can apply for jobs right away. The self-learning path, I would say, is good for people who already are in tech. It's a lot easier when you have a foot in the door, or you can kind of have a foot in the door, you can see that next step when you're applying for jobs. Like if you teach yourself and you get some of these certifications, then you can apply for that data engineering next level job. But the boot camps are great in general for people who kind of want to go through this process, and at the end, they have they can apply for these jobs. Of course, the career services that these boot camps can provide, that is really key, because a lot of these boot camps put a mentor like me or Guy, with you, and we are there to help you get a job at the end. I'm going to give you guys a path to get this secret pad at the end of the webinar for getting a job. So our program is DataStack Academy. That's a URL. So if you can go to datastack.academy, you can get a lot of information about our program. You can also go to datastackacademy.com if you prefer. One of the big things there is a link to get our first 2 chapters. So we have a 10-chapter course, is very comprehensive, but the first 2 chapters, which is Python SQL, which is your basic knowledge, you can start that now. It's free. Go ahead and do that. Put those on your GitHub portfolio. That's a great
Can't
place.
stress that enough. Yeah, I mean, GitHub is the place where coding happens collaboratively. And as Parag mentioned, like if you're trying to get a job in tech, employers will vet you that way. They will look at your GitHub profile to see what you've done. So this is one of the best things, whatever your learning path is use GitHub, put projects on GitHub. Absolutely.
And there's link there to schedule a talk to me if DataStack is a thing that you look for, this bootcamp style. You can go ahead and apply, reserve your seat. We have limited seats, and we have a class starting in January. So go ahead and apply. I would highly recommend that. The course, as we said, I can say this with sincerely, this is the most comprehensive data engineering course that we've put together. It's 10 chapters. It will teach you all the main tools that we've talked about here. And what's important, that we teach you these skills on the cloud. We can't stress that enough. Again, you have to learn these things on the cloud. The reason that you're here on a GCP talk shows that you already know that, so I won't go that into detail. But our skills, every one of these skills that we teach you those skills on the cloud. We've chosen Google Cloud for our course because actually it's the cleanest, it's the best that we think. It doesn't have like a Byzantine of services like Amazon, Azure I would highly recommend as well. But Google Cloud also, it's because a lot of these open source technologies, they're taken from open source. Google, the cloud vendors, change them a little bit and then offer those service on their cloud. Google is the closest to the true open source technology. So if you learn these on Google, then that knowledge is easier transferable to Azure or AWS if you want to. That's it. Sorry again, we tried to go through this as quick as we can because we knew it was very slide heavy, a lot of words. But we welcome you. Go there on DataStack Academy. But this is now open to everybody. If you guys have questions, you can ask questions and we'll be happy to answer those. We wanted to make sure actually we'll leave time for this portion. So go ahead. Please, I welcome everybody to go off mute. Please talk to us, introduce yourself. We love to talk to you always. let's see if there are questions. Do I see any questions? CJ, do you have any, do you see any questions up? Awesome. Enjoy subreddit. Okay, great. Yeah, nice. We love Reddit. We love that subreddit tab, and we're there. Guy and I are there posting. I haven't been there for a day, but I'm gonna get to it today for sure. It's I mean, I love Reddit.
Looks like people are finding us through various ways, so we're excited about that. However you showed up at the webinar, thank you for being here. We're excited about people's interest and glad to have you.
Yeah. Do you guys have any particular questions? Again, please feel free to go off mute. Tell us if this was useful for you, if you found this webinar useful. Tell us if it wasn't. Please tell us how we can change it. If there's some more information that we can put here in follow-up webinars. We're always improving these.
And we'll post the slides later. So those are heavily linked with other resources. There's some cloud architectural, different articles and things. So if you're interested in more details, we'll post that after the webinar, and there's lots of other resources in the notes for the slides. So take a look at that too.
Take a look at that. So we send the slides with the notes. So the notes section in the slides has pretty much what we talked about, but also a lot of resources where we got our information from, which you can link to. And we would love to see you on DataStack. So go there, please register. You can schedule a call to talk to me directly if that's something you're interested in. I would love to talk to you as well. All right. There's not too many questions. Maybe we're early for once.
It doesn't look like we have too many questions, but yeah, I think everybody knows where to find us. And either one of us is glad to talk to you, glad to answer questions. DataStack.academy has a lot of resources. So yep, go take a look. You can check out the first 2 chapters. If you click the get started for free button, and you can see a little bit more what the course is about, get some more details there.
Thanks a lot, guys. With that, I am going to stop the recording and end the webinar. Again, don't be a stranger. Thanks again everybody for joining. All right, take care.